Okay, continuing on in Unit 5, we're going to talk more about solutions and solubility. For Unit 5, we discuss salts, or I say salt a lot, and you might think salt is NaCl. It is true that NaCl is a salt, but there are many other compounds that can be classified as salts. So when I refer to something as a salt, I am referring to any ionic compound. And remember that ionic compounds have metal to nonmetal, have metals to nonmetals, or any polyatomic ions. And remember those polyatomic ions: ammonium, hydroxide, cyanide, sulfate, sulfite, nitrate, nitrite, and so on and so forth. So anytime I say salt, I'm not just talking about sodium chloride, I'm talking about any ionic compound. Yeah, we had talked a little bit about this in Unit 2. When you see S in parentheses, that means that you have a solid. So this is when you see S in parentheses for chemical reactions. So if it's solid, that means that it is insoluble. Insoluble. So it's not dissolving in the solution. If it's AQ, on the other hand, aqueous is what AQ stands for. It means it's soluble and it's dissolved in water. So solubility is more complex than you might imagine. We talked about electrolytes in the last lecture, and there's a component of dissolving something, and then there's a component of these ions being formed, so ionization or dissociation. So in order to predict whether something is going to dissolve, there are some solubility rules that we'll learn. So, if you remember, we talked about sugar, and you know that sugar dissolves in water, but sugar does not ionize. So it's a non-electrolyte because it does not conduct electricity, but it is soluble. It will go from S, it will go from being solid to aqueous. So now we're going to learn these solubility rules. And these solubility rules are very useful for Unit 5. I would say it's very difficult to get above a 60% on the Unit 5 exam if you don't memorize these solubility rules. So I've had students come up with a lot of crazy things to memorize these solubility rules. Whatever you need to do to memorize these, do, aside from cheating, right? But seriously, write these out every day. Make up a song, make up a saying, whatever you have to do. These solubility rules are very helpful for Unit 5. So, the first rule is salts that contain lithium, sodium, potassium, rubidium, cesium, ammonium, and nitrate are always soluble. So you might think, oh my gosh, these are ridiculous. I can't memorize these rules. Well, if you look on your periodic table, lithium, sodium, potassium, rubidium, and cesium, these are all group 1 elements. So you can say all group 1 elements, ammonium and nitrate, are always soluble. Now when I say soluble, does that mean I get put an S next to it or an AQ? Well, look back up here. S is for insoluble, AQ is for soluble. So that means that salts that contain group 1 elements, ammonium and nitrate, are always AQ. Okay, so that's the first rule. The second rule, salts that contain chloride are soluble except for silver chloride and lead 2 chloride. So anything that contains chloride would be AQ, unless it's AgCl or PbCl2. If it's those, then they get an S, which means insoluble. So you have to be careful. A lot of students mistake S for soluble. S is insoluble, so just be careful with that. Okay, the third rule, salts that contain sulfate ion are soluble, so they get the AQ, except for barium sulfate, lead sulfate, and calcium sulfate. So these would be solids. And then the last rule, salts that contain hydroxide, carbonate, sulfide, and phosphate are insoluble, so that means they get an S, except those with group 1 or ammonium. So then these would get AQ. So in the fourth rule, a lot of students say, well, why couldn't you say nitrate as well? So they would prefer the rule to say salts that contain hydroxide, carbonate, sulfide, phosphate are insoluble except those with lithium, sodium, potassium, rubidium, cesium, ammonium, and nitrate. Well, the reason nitrate is not included in rule number 4 is because it's also an anion. You're not going to have hydroxide and nitrate forming an ionic compound, right? There's no attraction between these negative charges. There's no electrostatic attraction. They're going to be repelled by each other, in fact. So that's why nitrate is not in the fourth rule. Okay, so these solubility rules are going to be the center of predicting reactions. And so it might seem like a stretch right now because we just learned them. But part of what we need to do with these reactions is predict which salts, which ionic compounds, will be insoluble. So I have many different salts at the bottom of page 6, and I want you to circle the insoluble salts by applying these rules. So when I say insoluble salts, remember that I'm looking for salts that will be solid. So I want you to hit pause and work on these. Alright, so hopefully you got 10 insoluble salts. Sodium phosphate, Na3PO4, is soluble because it contains sodium. Calcium hydroxide is insoluble because it contains hydroxide, and calcium is not a group 1, so that's why I circled it. PbCl2 is insoluble, see Rule 2. Silver sulfate, you might think is insoluble, but look to Rule 3. Salts that contain sulfate are soluble unless it's barium, lead, or calcium. So silver is not barium, lead, or calcium. That's why it's soluble. A lot of students circle RBOH, rubidium hydroxide. But remember, see rule number 4. Salts that contain hydroxide are insoluble except those paired with group 1. RB, rubidium, is in group 1, so it's soluble. Magnesium sulfide, see rule 4. So it contains sulfide with a group 2 element, and so it will be insoluble. The next row, ammonium phosphate, all salts with ammonium are soluble. So that's why I didn't circle that one. Iron 2 sulfate, all sulfates are soluble except for barium, lead, or calcium. So Fe is neither of those three. FeCl3, iron 3 chloride, see rule 2. So if it were Ag or Pb, then I would have circled it, but since it's iron, it's soluble. Calcium sulfate, see rule 3. That's why it's insoluble. Strontium hydroxide. Strontium is a group 2 element. So rule 4, salts that contain hydroxide are insoluble unless paired with group 1 or ammonium. So since strontium's in group 2, that's why it's insoluble. The next one, aluminum sulfide, again is rule number 4. So we have sulfide being paired with something other than a group 1 element. Alright, the next row, silver chloride, see rule number 2. Magnesium phosphate, this is rule number 4. Magnesium is not a group 1. cation or ammonium. Barium sulfate is insoluble if you look at rule number 3. So sodium hydroxide contains a group 1 element, so it's always soluble. So I didn't circle it. Calcium carbonate, see rule number 4. Calcium is not a group 1 element, so that's why calcium carbonate is insoluble. And lastly, MgCl2, magnesium chloride. A lot of students think this would be insoluble as well, but salts that contain chloride are insoluble or soluble except for silver chloride and lead 2 chloride. So since Mg is neither Ag or Pb, that's why it's soluble. So hopefully these rules are starting to stick. Write them down, review them. They are very useful. Now we're going to apply these solubility rules to reactions, and you will have a reaction section on your exam where these rules will be applied. So like I mentioned earlier, it's very hard to be successful at the Unit 5 exam if you don't memorize your solubility rules. So the first type of reaction where we're going to apply our solubility rules is to dissociation reactions. Remember that dissociation reactions, you have a compound, I'll just say X, Y, in a solid state. You add water. If it's a strong electrolyte, then it breaks up into its component ions. So this reaction will hold true if you have a strong electrolyte and it's soluble. So here is where you have to apply the solubility rules. So if a compound is insoluble, according to your rules, see solubility rules. So if it's insoluble, F, there's no reaction. Now a lot of students think that every compound, because it starts off in the solid state here, will have no reaction. You have to apply your rules to this to predict whether you're going to have a reaction or not. Remember that we're taking these ionic compounds, and ionic compounds are solid. You go to the store, you buy these ionic compounds. They're going to be in a solid state. That's the nature of ionic compounds. And so they're all going to start off solid. When you add them to water, depending on if they're soluble or not, they will stay solid and they won't dissolve, or they will become aqueous and ionized. So you have to apply your solubility rules. So the second thing I have written here, if a compound is soluble, AQ, it breaks down into its component ions. So with this reaction here, I have an ionic compound that is soluble and it's a strong electrolyte. So that's why it broke into its component ions and AQ. So let's go through a few of these. This first reaction, I have silver chloride. When I add it to water, will it be soluble? Well, let's go back to our solubility rules on page 6. Remember the rule, rule number 2, salts that contain chloride are soluble except for silver chloride and lead 2 chloride. So silver chloride is not going to be soluble. So since it's not soluble, I will have no reaction. So if you put silver chloride in water, you would just see solid at the bottom. If you tried to determine if electricity is conducted in this solution, you would get a very low reading, no electricity. So it would come out to be a non-electrolyte because it's not soluble, even though it's an ionic compound. So you have to be careful with these reactions. Previously, before we learned our solubility rules, we thought, if it's an ionic compound, then it's going to be a strong electrolyte and it's going to ionize. Now we've learned more. So now you have to say, is it an ionic compound? If it's an ionic compound, is it soluble? If it's soluble, then it will ionize completely. So let's go to the next one. Iron 3 chloride, when you put this in water, will it dissociate or ionize? Let's go back to our solubility rules. Salts that contain chloride are soluble except for silver chloride and lead chloride, lead 2 chloride. So since it is soluble, we will have it breaking down into its component ions. So it's soluble. So when it ionizes, iron will have a +3 charge, and chloride will have a -1 charge. And put the aqueous by each of these, because we just went through the solubility rules. Now, with these dissociation reactions, you have to make sure they're balanced. So I have 1 iron on the left, 1 iron on the right. 3 chlorides on the left, 1 chloride on the right, so I have to put a coefficient of 3 here. So now that is balanced. So iron 3 chloride would be classified as a strong electrolyte, Se, strong electrolyte. All right, this next one, nickel 2 hydroxide. First, check to see if it's soluble or not. Oh, it's got a hydroxide. Salts that contain hydroxide, so I'm looking at rule number 4. Carbonate, sulfide, phosphate are insoluble except those with group 1 and ammonium. Is nickel a group 1 or ammonium? No. So this is not soluble, so I'll get no reaction. Alright, so I want you to go through the next 4 reactions and apply your solubility rules. If they are soluble, then they're going to dissociate. Okay, so sodium sulfate, since it contains group 1, is soluble. So it will ionize. Make sure it's balanced. Copper 2 chloride is soluble as well. So it will ionize. Copper 2 plus and 2 chlorides. Barium sulfate is not soluble. So you get no reaction. And then silver sulfate is soluble. So you get it breaking down into its component ions. So now you have to go through and apply these solubility rules when you see these dissociation reactions. So there's some great practice problems in your pink book for dissociation reactions. So practice, practice, practice. There are also some good ones on Blackboard. Now the other type of reaction that we're going to apply our solubility rules to is precipitation reactions. So also known as double displacement. And the way I like to present double displacement reactions is you have 2 couples dancing and then they switch partners. So the cations are always going to go with the anions. So in this double displacement reaction where I have A, B, and C, D, A is my cation, B is my anion, C is my cation, D is my anion. So they're going to switch partners, and the cations are going to go with the anions. So A is going to go with D, and C will go with B. So my products, or my new couples, will be A, B, and be careful on this one. Remember that cations are always written first, so it's not going to be BC, but instead CB. Now, if the products are both soluble, meaning that you consult your solubility rules and you see that both of these are AQ, then there will be no reaction. If either or both products are insoluble, meaning that you have a solid formed, there is a reaction. You might think, well, this is kind of strange. But think about what precipitate means. This means to form a solid. So these precipitation reactions only happen if a solid is formed. So one of these has to be a solid in order for the reaction to go forward. So you have to consult those solubility rules. So let's look at this first example that I have. Sodium chloride and silver nitrate. Predicting these reactions is great practice for you. It's a good way to study for the final. So we're really reviewing a lot from Unit 2. So this is what your reactions will look like on quizzes or exams. I will have reactants and you're to predict the products. So the first step is to determine the ions in the reactants. So kind of step backwards. Well, sodium chloride is made up of sodium ions and chloride ions. Silver nitrate is made up of silver ions and nitrate ions. And hopefully you're starting to see how much more we see polyatomic ions in Unit 5. So if you're rusty on your polyatomic ions, you're going to need to review them. And it will help you in so many ways. Okay, so the first step, determine the ions in the reactants. We've done that. The second step is to do a double displacement to determine the possible products. And remember that cations are always written first in formulas. So we're going to switch partners. So sodium is going to go with nitrate and silver is going to go with chloride. And you have to apply the rules of writing formulas that we learned in Unit 2. So with these ions, we have just +1 and -1. So we're not going to need to have more than one ion. It's just going to be a 1-to-1 ratio. But there will be cases when you have different charges, and so you're going to have to do the cross and drop like we learned in Unit 2. So we're going to write out the products of these. So Na sodium nitrate, and then silver chloride. So we have determined the possible products. We've written the cations first. So now we're going to move to the third step, which is to determine the solubility of the products. If they are all soluble, meaning AQ, there is no reaction. So let's see, is sodium nitrate soluble or insoluble? Consult, rule number 1. Sodium nitrate always soluble, so you could put an AQ here. Now silver chloride, consult rule number 2. All chlorides are soluble except for Ag and Pb, so this is going to be an S. So since we have an S, and this is a precipitation reaction where we have to have a solid forming in order for it to occur, this reaction will go forward. Now, the fourth step is to balance the reaction. At this point, this reaction is balanced. So 1 sodium, 1 chloride, 1 silver, 1 nitrate, 1 nitrate. So it's already balanced. But with these precipitation reactions, not only do you have to write the correct formula and the product, you also have to put your state symbols, meaning you have to tell me if it's AQ or solid. Very important, and then make sure they're balanced. All right, so let's have some practice reactions for you. And let's skip to the second one. I want to work this one with you. Potassium phosphate and nickel 2 nitrate. The first step, break the reactants up into their ions. So potassium is +1, phosphate -3, nickel is +2, nitrate is -1. Now we're going to switch partners, so potassium will go with nitrate, nickel will go with phosphate. This is the point where a lot of students make mistakes. If you write the incorrect formula for your product, you're going to have a very difficult time balancing these. So if it helps, in the beginning, you can write out your ions and then do the cross and drop from there. Okay, so 1-to-1, so that formula would be KNO3, and then this one would be Ni3PO4 2. Okay, so we've gotten the formulas of the products. Now we have to determine whether or not they're soluble. So potassium nitrate will be soluble because it contains a group 1 element in nitrate. So I'm going to put an AQ by that. And then nickel 2 phosphate. Consult rule number 4. Oh, let's go back to it. Salts that contain hydroxide, carbonate, sulfide ion, phosphate ion are insoluble except those with group 1 or ammonium. And we have nickel, so it's not group 1 and it's not ammonium, so it's going to be a solid. So this reaction will occur. Now we have to go through and balance it. It's definitely not balanced. If you look at the potassiums, you have 3 potassiums on the left and 1 on the right. So that's off. Also, we have our phosphates are off. So if you look at the phosphates on the left, you have 1 phosphate on the left, 2 on the right. So let's put a 2 in front of potassium phosphate. Now we have 6 potassiums, 2 phosphates. The phosphates are balanced, but the potassiums are off, so we'll have to put a 6 here. Now we have 6 potassiums, that's good. 6 nitrates. So we need to balance that on the left, so we'll put a 3. Now I have 3 nickels, and I have 3 nickels. So 3 nickels on the left, 3 nickels on the right. So that's balanced. So my coefficients are 2, 3, 6, 1. So it can't be further simplified. And this reaction does occur because I have a solid being formed. Let's do the next one together. Zinc nitrate and potassium sulfate. So zinc plus 2, nitrate minus 1, potassium 2, sulfate minus 2. We do the switch. Potassium goes with nitrate, zinc goes with sulfate. So I get ZnSO4 plus KNO3. Now I have to consult my solubility rules. All sulfates are soluble unless barium, calcium, or lead. So this first one is going to be soluble. And then potassium nitrate, group 1 nitrate, always soluble, so I get AQ, AQ. Does this reaction occur? No, because remember, these are precipitation reactions. You must have a solid being formed. So if you'd gone through and written all this out on your quiz or exam, you can just cross it out and write no reaction. Don't even have to worry about balancing it, because it doesn't happen. So at this point, you have 3 more reactions to work through. I want you to work through these reactions, and then when you resume, I'll go over them. Okay, so all of the reactions that you did on your own did proceed because they all formed solids of some sort. So the first reaction, ammonium sulfate plus barium nitrate, gives you ammonium nitrate, which is soluble, and barium sulfate, which is insoluble. Had to balance it, so I put a 2 in front of ammonium nitrate. And then the fourth reaction down, sodium sulfide plus iron 3 nitrate, gives you sodium nitrate and iron 3 sulfide, which is insoluble. So the reaction does proceed. It needs to be balanced. It's balanced by putting a 3 in front of sodium sulfide, a 2 in front of iron 3 nitrate, and a 6 in front of sodium nitrate, and a 1 in front of iron 3 sulfide. The last reaction proceeds as well. Lead 2 nitrate plus potassium sulfate gives you potassium nitrate and lead 2 sulfate. Lead 2 sulfate is insoluble. It needs to be balanced by putting a coefficient of 2 in front of potassium nitrate. Now, like I mentioned earlier, if you have the incorrect formula for a product, you could potentially spend a lot of time balancing these reactions. So You know, if it's not working out, you probably have the incorrect formula. So always double check your formulas. And, you know, if you have to do the cross and drop for a while, by all means do it. It will become easier. There are tons of practice precipitation reactions in your pink book. I highly recommend practicing these. Also the dissociation reactions that we covered. These are very, very difficult for students, especially if you don't know your solubility rules. So the only way to get better at these is to practice, practice, practice. So, work on mastering your solubility rules. Work on the homework problems that pertain to the sections we covered today. Also work on that pink book. So, until next time.